So it is my pleasure to welcome you all at this first legal workshop on Safe by Design. I'm Anthony Beauchamp, and I'm in charge with my colleague of the legal aspects in this project. And we have organized today's workshop as part of our effort in one of the work packages of our project to cover the non-technical, non-entirely scientific aspect of Safe by Design. And the legal aspect is, of course, very central because, of course, we discuss about a safe by design or safer by design approach. There will be room for discussion about this concept this afternoon. But of course, law is often something coming at a later stage. And the great advantage in this project is that we cover these legal aspects also. And the purpose of today's workshop is to bring together, and that's quite exceptional, lawyers and also scientists to discuss together, to think about how law can address the challenges of safe or safer by design approaches. We have today quite a number of very distinguished speakers who will cover different topics which were considered as being relevant in order to feed the discussion and give us more insights on the regulatory challenges of a safe by design approach. After the short presentation of a project by Professor Andrew Nelson, our coordinator, we will have two presentations on safe by design approaches in the current regulatory regimes. We will have the Asian perspective with Professor Mohammad Eshadul Karim from the University of Malaya, who will give us, he's really an expert, a top world expert on nanotechnologies regulation. And we are very glad to have him here today. It's already night in this time zone, and we are very happy to welcome him at this workshop. After his presentation on the Asian perspective, very broad, you will have a presentation on the EU perspective that I will have the pleasure and the honor to present to you all today. After a short break, we will have a more global perspective on regulatory challenges with the by design approaches and interdisciplinarity presentation by Dr. Mirella Mittinen from the University of Eastern Finland. And a presentation is one of the outcomes of a publication, I would say a landmark publication on the legal aspect of safe by design, which was published last year. Then some members of a project will present in a 1 hour time frame the literature review that was carried out in our project during these last months. We will have Dr. Benjamin Trump, who will present on the literature review from a more scientific perspective, and Ignacy Gispert, who will give a presentation much more covering the legal aspects and especially what we can do on the basis of this literature review. We will then be later joined. He's in a totally different time zone. Currently, it's night for him. It will be morning for him when we'll join. It's Professor Ira Rubinstein, a former Deputy General Counsel, Worldwide General Counsel of Microsoft, who will give us a presentation on technologies by design, especially the lessons that we can draw from privacy by design. So it's a totally different technological area. We speak here about data protection, but very interestingly, we see that there is another principle, that is to say, protecting a certain interest by design and applying this principle at the earliest technological stage possible. That will be extremely interesting, especially if we think about greater convergence between technologies and therefore greater convergence between regulatory regimes. We will close today's workshop with a roundtable with 6 panelists. 5 of them are members of a project, and we have also Professor Fernand Dorido, we have Professor Andrew Nelson, Professor Maja Dusinska, Dr. Igor Linkov, Dr. Benjamin Trump, and Ignacy Gispert. And we will close today's workshop. Hopefully, we will manage it in a 6 hours time frame with some conclusions and especially announcement about what's coming next for our project. I now give the floor to Professor Andrew Nelson to make a short presentation on our project. Thank you very much.
Thank you very much. Can you all hear me, I hope? Thank you very much for a brilliant introduction. So I'm going to keep it down to 15 minutes exactly. My clock's between 5 past and 10 past. I just want to say I've always had a big interest in philosophy and ethics and legal aspects of science and chemistry and nanotechnology. And in fact, we ran a course in Leeds University on this, and it was a great pleasure that I was able to bring in Anthony Beauchamp into the project, so it produced a novel arm to the general nanotoxicology. So SABYDOMA applies a control theory to a safety by design paradigm. And when you consider safety philosophy in any health and safety regulation, you either take a precautionary principle, which applies the general view that if the public perceive there's a risk from something like nuclear power or sewage sludge dumping in the environment, you immediately take steps to ban it on the basis that it's better to be safe than sorry if there's any outcome which is hazardous in the future. And there are many, many examples of this. I can, for instance, sewage sludge dumping, certain aspects of radioactivity, and so on. The other side of the coin is to base your control of that hazard in terms and risk, consequent risk in using evidence-based decisions, which we call EBD. And here you develop refined and sensible decisions on the basis of scientific evidence. So, for instance, if there is direct discharge of sewage into the sea, instead of banning it, you monitor the levels of sewage in the sea, which is your scientific approach, and you get results, and you base your decision on the dumping or the discharge of sewage depending on the science that you get. So if you find it's having a deleterious effect on the environment, then you take a decision to restrict the sewage discharge. Okay, and it's on evidence-based decisions that safety by design takes its base. So you can take this into an environmental context. I've already talked about the sewage discharge or pollutant discharge into the river. You can either ban it or you can control the discharge through monitoring the levels continuously. With climate change, you can either ban all carbon dioxide emissions, or you can actually control, you can measure the level of carbon dioxide in the atmosphere, and if it goes above a certain level, which is going to accumulate in the atmosphere, you can control your carbon dioxide emission, and that's an evidence-based decision. So here we have a control system technology which underwrites all evidence-based decisions, and the red arm, it's a circle as you can see, and the red arm of that circle is based on safety. It's the actual monitoring or measurement, and as you can see on the left-hand side, it's feeding back results of screening, if you like, or the scientific evidence is feeding that back into a control, which is the cross in the circle, and this controls your production or your discharge, which is the top end of the control system. So I see always as a safety by design or basing your control of hazard on evidence-based decisions as in fact a simple control system. Okay, in terms of nano toxicology or nano safety, The bottom line there that completes the circle is in fact the nano material screening, and you receive a certain results from the screening, and these results you compare with what you want in the production, and therewith you modify your design and you continually produce safe nano. And if the screening results go above a certain level of toxicity, you have to modify the design. And that's the basis of SABYDOMA. That is the basis of SABYDOMA. And we've applied this in a technological solution or platform in our project. Yeah, and when you get to more specific, this is very, I'm going to be very quick here. On the top, we have the production. On the right-hand side, we have the screening. The whole essence of SABYDOMA is to screen at the point of production, and then we produce results from which we get a tox score, which is the toxicity of the material, and then we compare that tox score with the set what we want as a toxicity, which is accordingly safe, and from that we modify design. And this is the basis of the SABYDOMA technology. Okay, so why did we get this idea? Well, I've already discussed I had the philosophy in my mind for years and years and years because I'm an environmental scientist originally. But we also got this idea from our last project in HISENTS. Thank you, the EU, who supported it. And in the HISENTS, we did away with the well plate system of screening in nanotoxicology and also in normal conventional toxicology. And we used a system of flow cells with different targets. And we cycled media through these flow cells, and we recorded our results from each target, and each target was a particular organ or organelle in the mammalian physiology, and from there we were able to build up a very good picture of the toxicology of a certain material or chemical to the organism using basically a flow system which mimicked the mammalian physiology. Okay, so what did we learn from HISENTS? I'll be very quick. Basically, we learned 6 points. Nanomaterial changes its property rapidly after production. For screening of nanomaterial to be effective, it's got to be therefore done quickly. We've got to effectively couple screening with design to have an effective nano safety technology procedure. Everything's got to be flow through. The production and the screening must be flow through, and rapid flow through screening and production minimizes workers handling and maximize efficiency and safe nano production. So this is again going through the control system. We had to get it down to a specific platform, and here you can see again and again, we produced nanoparticles in a reactor, flow through reactor, and we screen it at the point of production, and we get a result you can see on the computer, and this modifies our nanoparticle production. Okay, so we also underwrite the whole technology with computer modeling, and in one case, the computer modeling develops software which looks at quantitative structure activity relationships of the relation of the nanomaterial to its biological effect, so we can assess from the physical qualities of nanomaterial its actual toxicity, and we can feed that into the design so we develop safe nano. The other thing is actually modeling the control system, which our colleagues in Athens are currently doing really well. And in this way, we can actually simulate the control process, the control system process in the production of safe nano. Okay, we combine this all up using our technology and our mathematical modeling simulation, and we get the circular model. You can see where we're screening using all those mathematical techniques and also the physical techniques. We're feeding that to design to control our production. And then we complete what we call the lead demonstrator, which is one of the final big jamboree outputs of the technology. And there you can see on the top, again, we've got our production in a very sophisticated way of nanomaterial, and then it's being screened by lots of different systems, UV, everything, and the screening results of feeding back to production. That's the final output of the whole SABYDOMA project. Okay, we're also engaged in a release study program, which is entirely compatible with the control system idea, where we're putting our coatings from two technologies into a flow cell. We're leaching them with different materials, causing release. We're then screening those leachates, and we're feeding back the screening results to moderate our coating, which varies for implants to electroplated coating. Okay, one particular aspect of SABYDOMA is transferring all its technology to companies, and we're working with 4 companies. 2 of those companies are actually manufacturing nanoparticles, and we're going to transfer our screening and production system to them. We're working with them very closely. And 2 of the other companies are developing the coatings and using the aforementioned technology I talked about in the previous slide. We're going to screen those coatings. So we're going to develop our technologies up to TRL 6 level, and you can see the thrust of the project going through all those 4 case studies on the left hand side. We've also got a very big regulation and governance side, and that's why we're having this workshop. Okay, thank you very much for your attention.